Numbers are one of the most fundamental concepts in human thought. They shape the way we understand the universe, allowing us to measure, calculate, and predict. But where did they come from? How did humanity go from simple tally marks to the sophisticated number systems that underpin modern science and technology? The story begins tens of thousands of years ago. Early humans needed a way to keep track of quantities, how many animals they had, how much food was stored, or even the number of days in a cycle. The simplest method? Tally marks. Archaeologists have discovered bones with carved notches dating back over 30,000 years, showing that even our distant ancestors recognized the importance of counting. As societies grew and trade developed, the need for more advanced number systems became apparent. The Sumerians, around 3000 BCE, were among the first to create a structured numerical system. Their base 60 system, yes, the reason we have 60 minutes in an hour and 360 degrees in a circle, allowed them to perform calculations and keep detailed records of commerce and astronomy. The Egyptians, around the same time, developed their own number system based on hieroglyphs. It was primarily additive, meaning they repeated symbols to represent numbers, making calculations tedious. Yet, it allowed for remarkable architectural feats like the pyramids. The Babylonians took number systems further, refining the base 60 approach and introducing place value. A critical breakthrough that made calculations far more efficient. Around the world, other cultures devised their own numerical systems. The Mayans developed a sophisticated base 20 system, while the Chinese created an early decimal system. But one of the most profound mathematical revolutions came from India. The Hindu-Arabic numeral system, developed between the 1st and 5th centuries CE, introduced the most powerful concept in all of mathematics: zero. While other civilizations used symbols for empty spaces or placeholders, the Indian scholars treated zero as a number in its own right. This innovation, combined with positional notation, made arithmetic operations far more efficient. The system was later transmitted to the Islamic world and then to Europe, where it eventually became the global standard. This transformation didn't stop with whole numbers. Over time, humanity expanded its understanding of numbers to include fractions, negative numbers, irrational numbers like pi and square root 2, and even complex numbers that include the imaginary unit I. Each new development allowed for deeper insights into the fabric of reality, from describing the motion of planets to engineering the most advanced technologies of today. The evolution of number systems is not just a tale of history, it is the foundation of all mathematical thought. Without these developments, science, engineering, and modern technology as we know them would not exist. And yet, the journey is far from over. As we continue to explore mathematics, we uncover even more profound questions about the nature of numbers and their role in the universe. This is another step forward in our journey. Mathematics is a language, one that has been refined over millennia, each generation building upon the discoveries of the past. As we move forward, we will see how numbers form the foundation of all mathematical structures, leading us to deeper insights and more powerful tools to understand our world.